In 1986, a group of 7 astronomers sat down with a problem that had no clean answer. They had spent years mapping the velocities of galaxies across a wide swath of the observable universe, measuring not just where things were, but how fast they were moving and in what direction. What they found did not match the models. Galaxies across an enormous region of space, thousands of them, including our own Milky Way, were not moving the way they should have been. They were drifting, streaming, being pulled coherently and relentlessly toward a single point in the sky. The group, later nicknamed the Seven Samurai, calculated the scale of what would be needed to produce this motion. It had to be a concentration of mass so immense, so gravitationally dominant, that it was bending the flow of galaxies across hundreds of millions of light years like water circling a drain. They named it the Great Attractor. And then they went looking for it. What they found, or rather what they could not find, is one of the most unsettling stories in the history of modern cosmology. Our galaxy, the Milky Way, is not sitting still. Nothing in the universe is. We orbit the galactic center once every 225 million years. The Milky Way itself is moving relative to the cosmic microwave background, the afterglow of the Big Bang, at roughly 600 kilometers per second. That is fast, incomprehensibly fast, fast enough to cross the distance between Earth and the Moon in about 10 minutes. But embedded within that raw velocity is a component that astronomers could not fully account for. A directed pull, a peculiar velocity that pointed every galaxy in our local volume toward a specific patch of sky in the direction of the constellation Centaurus. Not some galaxies, all of them. Everything within a region roughly 500 million light-years across was being funneled, slowly and irresistibly, toward the same gravitational sink. To understand why this is so disturbing, you have to understand the scale. 500 million light-years is not a neighborhood. It is a staggering fraction of the observable universe. The Milky Way contains roughly 400 billion stars. The Andromeda galaxy, our nearest large neighbor, is 2.5 million light-years away. The region being pulled toward the Great Attractor contains tens of thousands of galaxies, entire galaxy clusters, structures that dwarf anything in our local neighborhood, all of it streaming in the same direction. And the object, or structure, responsible for pulling them had to be more massive than anything we had yet confirmed existed. Early estimates placed its mass at the equivalent of tens of thousands of galaxies. A concentration of matter on a scale that had no precedent in the catalogue of known cosmic structures. And then came the problem that made this genuinely maddening. The Great Attractor sits almost precisely behind the plane of the Milky Way from our vantage point. Our own galaxy, with its dense disk of stars, gas, dust, and interstellar material, forms what astronomers call the zone of avoidance. It is not that we chose not to look there. It is that the Milky Way itself is in the way. Optical light cannot penetrate it. The dust absorbs, scatters, and distorts the signal. The very object responsible for the gravitational fate of our cosmic neighborhood is hidden behind the thing we live in. For years, the Great Attractor was a gravitational signature without a face, a force without a source. Astronomers knew something was there with mathematical certainty and could not lay eyes on it. The breakthrough came not from optical telescopes, but from instruments built to see what light cannot carry. Radio waves and X-rays penetrate the galactic plane more effectively, and as those surveys pushed through the zone of avoidance, a structure began to emerge. The Norma cluster, a dense concentration of galaxies sitting at the approximate distance and location predicted for the Great Attractor, became the leading candidate. It is a rich, massive galaxy cluster, the kind that anchors large-scale structure. But as better data accumulated, a more complicated picture took shape. The Norma cluster is real and massive, but it is not enough. The gravitational pull required to produce the observed streaming motion of galaxies across hundreds of millions of light-years is larger than Norma alone can account for. The Great Attractor, it turned out, is not the end of the story. It is a waypoint. Behind it, at a distance of roughly 650 million light-years, sits something even larger, the Shapley supercluster. It is the most massive concentration of matter in the observable universe, within 1 billion light-years of us. Its total mass is estimated at over 10 million billion times the mass of the Sun. It contains dozens of galaxy clusters, hundreds of groups, and tens of thousands of individual galaxies, all compressed into a gravitational knot so dominant that it contributes significantly to the peculiar velocity of our entire cosmic region. The Great Attractor and the Shapley supercluster are pulling in roughly the same direction. They are collaborating in a purely gravitational sense to drag our galaxy, our local group, our supercluster, and everything within hundreds of millions of light-years steadily, continuously, toward that corner of the universe. In 2014, a team led by Brent Tully at the University of Hawaii mapped the full extent of what they called the Laniakea supercluster. Using galaxy velocity data to trace the boundaries of gravitational influence, they defined our cosmic home for the first time with genuine precision. Laniakea means immeasurable heaven in Hawaiian. It stretches 520 million light-years across and contains the mass of 100 million billion suns. And it is not a static structure. It is a landscape defined by flow. Its galaxies are all moving, at varying speeds and from various distances, toward a single point at its heart. That point is the Great Attractor. We are not just near it. We are inside the structure it dominates. We are one of the tributaries feeding into that gravitational basin, and we have been moving toward it since before our solar system existed. What happens when we get there is a question with an answer that is both scientifically precise and cosmically humbling. We will not arrive. Not in any meaningful human sense, and arguably not in any cosmic sense either. The universe is expanding. Dark energy, the mysterious force accelerating that expansion, is pulling the large-scale fabric of space apart faster than gravity can pull things together across the largest distances. The Great Attractor is real. The streaming motion toward it is real. But the Shapley supercluster is already receding from us due to cosmic expansion. At its distance of 650 million light-years, the expansion of space is carrying it away. We are being pulled towards something that is simultaneously being pulled away from us. The race between gravitational attraction and cosmic expansion is, on these scales, one that gravity is losing. The Great Attractor will never be reached because the universe is ensuring the destination keeps moving. What we are watching, then, is not a journey with an arrival. It is a fossil of gravity. The streaming motions of galaxies across hundreds of millions of light-years are the echo of a universe that was once denser, more compact, and more gravitationally coherent. As space expands and structures dilute, these great flows will gradually dissipate. Future civilizations, if they exist and look out from whatever galaxy they inhabit, will see a universe that appears far more uniform and far less structured than ours. The Great Attractor, the Shapley supercluster, the filaments and walls and voids of the cosmic web, these things are features of a particular moment in cosmic time. We happen to exist during the window in which they are still visible, still active, still shaping the motion of everything around us. There is something almost vertiginous in sitting with this fully. You are on a planet orbiting a star, in a galaxy that is falling toward a gravitational structure 250 million light-years away, which is itself being tugged by something 650 million light-years away. And all of it is unfolding against a backdrop of expanding space that will eventually undo every connection gravity is working to maintain. The universe is pulling itself apart with one hand and pulling itself together with the other. And we are caught in between, moving towards something we cannot see, inside a structure we only named a decade ago, on a journey that will never end because the destination is always receding. The Great Attractor is not a threat. It is something more disorienting than that. It is a reminder that even at the largest scales we can measure, nothing is where it appears to be. Everything is in motion. Everything is falling towards something. And the forces shaping where we go have been at work since long before anyone was here to notice them. And that's it from this video. See you in the next one.